adding a little bit to what we did before. If you're multiplying decimals and you come up with something like this, let's say you are multiplying 0.2 times 0.3. Remember the hard, fast rules of decimals? First of all, they don't need to be lined up. Get that out of your head. Your first rule is to multiply like normal. In other words, this is going to be the same thing as 0.2. It's the same thing as 2 times 3. I'm going to get 6 in my answer. The question, though, is where does the decimal go? Well, what's the rule to find out where the decimal goes? You have to count decimal places. There's 1 decimal place there. There's another decimal place there for a grand total of 2. And then you start at the right side and come back 2 places, and then you go, oh no, I've only got 1 digit there. Well, Charlie, fear not, because
You had 0.
right, you have to have a 0 as a placeholder. And then you end up with 0.06. If you need to, if needed, you have to add zeros. And make sure the zeros go in front, not at the end. Okay, don't make it 0.60 because that would be completely wrong. How about this one? What if you have 0.05 squared? Don't jump and think you know the answer until you've actually thought about this for a while. This is 0.05 times 0.05. So I know 5 times 5. I know 25 is in my answer, but where does the decimal go? Ethan?
In between 2 and 5.
It does not go between 2 and 5.
0 before the 2.
It does not go before the 2. What did we just get done talking about? Ethan, how many decimal places here? 2. 1, 2. How many decimal places there? 2. That's a grand total of 4, which means I got to take the decimal and move it 4, 1, 2, 3, 4 places, and I need to put in zeros to hold the place down there. 500ths times 500ths is 25, what? 10 thousandths. Multiply by decimals, you actually get smaller than you start with. 1 more. How about this? What is 0.3 squared? 0.3 squared. Chloe.
0.09.
Correct, 0.09, because it's 0.3 times 0.3. You do get 9, but there's 2 decimal places, so you got to go back 2 places. Got it, good. Blank piece of paper. The other thing they talk about in this lesson is circle graphs. Circle graphs, or pie charts, or pie graphs, they are also known as pie charts, pie graphs. Anybody, why and when do we use circle graphs? When is the appropriate time to show pie graphs? What do pie graphs tell you? Why do we use a circle? Why do we not use a bar graph? Why would you use a circle graph instead of a pie graph, Charlie?
Because it shows the percent.
It does, but what are you doing in all pie graphs there? You can show percents. Pie charts are when you are splitting up something whole into pieces. Pieces, kind of. Splitting a whole. Now, for example, let's just do this for fun here. Let's say I'm taking a little survey of the 6th grade. What is this, Qualcheck?
No. Success.
Oh, success, that's the way we spell success. And in this chart, I am just simply asking the 6th grade class, if you had to pick between a dog, between a cat, or between a fish, which of these pets would you choose? You can only pick one. So quickly give me your rendition there. Olivia?
Dog.
Dog. Charlie?
Dog.
This is not going to be fun if everybody picks a dog. John?
Dog.
Ephraim?
Cat.
There we go. We got somebody. Somebody give me a Leah? Oh, yeah.
Dog.
Chloe, what? Dog? Sam?
Fish.
Thank you. Work with me here there. Connor?
Fish.
Ooh. Fish. Ethan?
Cat. Fish.
Oh, how many of you are being honest here? Lilia?
Cat.
No, please don't let the cats win. Lacey?
I hate cats.
Ronnie?
Dog.
Fish.
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 Trevor?
Dog.
And Kate?
Dog.
Alright. So here's the deal. I would use a circle graph to show what piece, I would put pet choices. And here is how we would split that up. We know, first of all, what there's 15 of you, right? So my fractions of these, this is what? 8/15ths. Doesn't work out nicely. This is 4/15ths, and this is 3/15ths. And I need to split my little circle so that it represents what chunk of the pie each one gets. And again, it's because there's 15 of you, it doesn't really work out necessarily even, but 8/15ths is awful close to what? Half, right? It's a little over half, is it not? What would be half of 15? 7.5. So we got a little more than that. So we're only going to get close because I didn't use those numbers. So rather than doing half, so I need to make this just a touch bigger than half. So I'll go off. Oops. I need to go off on a little bigger than a half angle. Go like this. So here, my little blue chunk right here, man's best friend is the dog. By the way, could we tell exactly what percent 8/15ths is? Anybody know what percent 8/15ths is? How could we figure it out? Anybody? I don't think we have a 15th circle piece. You could do this, by the way, if you really want to know what percent it is. You want to know what 8/15ths of 100% is. So, do you remember doing that? You'd have to divide 100 by 15. Wow. How many times does 15 go into 100? 6. What's that? 90? 6 and what?
6 and...
Oh, it just keeps going. It just keeps going to point. It's like 6. It's like 6. It's like 6.6 and 2/3. It's 6.6 repeater. 6 and 2/3. And we have 8 of them. No, we're not gonna talk about that. It's going to be 48, it's going to be whatever. We'll just do it. Now, 4/15ths then, let's make them a different color. Cat lovers of the world unite, let's go pink. 4/15ths is awful close to what?
1/3.
Is it closer to 1/3 or 1/4?
It's in between both.
It is.
It's both.
But which one would be close? 4/12ths. 4/12ths is 1/3 and 4/16ths is
I'm saying
1/4.
5/15.
So we'll make it just a smidge smaller than 1/4. 1/4 would go from here to here and then straight down, but we'll go up on a little bit of an angle like this. Here are our cat people. Boo, boo, and boo. Cats are never been man's best friend.
No.
It's like He-Man. Big orange.
And then 3/15ths left, which actually is 1/5. That would be our little chunk left here. Our 1/5 is our fish lovers of the world. Fish never hurt anybody, by the way. Unless they're like
I'm like, fish are everywhere. Fish
A little
are
bit smaller.
everywhere. Don't forget the dog.
Fish or
Point being, children, just looking at the pie chart, you know, it's just an easy way to organize data that you can tell dogs are kind of the favorite of almost half people, cats and fish come around. If you look at your books, page 209, please. Let's just look at problem number 23 of lesson number 40. Where it talks about the circle graph, just to make sure we're all on the same proverbial page there. The circle graph displays the favorite sports of a number of students in a recent survey. Answer the questions. How many students responded to the survey? Well, obviously, to figure that out, you'd have to add all of them together. Sam, how many, if you add all those people together, how many? There would be 30 students there. So the answer to A is 30. Letter B says, what fraction of the students named softball? Well, they asked you why 30 because 30 will be the bottom number. How many out of the 30 like softball? Ephraim? 530, so make sure you reduce that, which reduces down to divide both by 5, 1/6. And then letter C asked you what percent like basketball. Well, how many like basketball? 15 out of the 30, which is 1/2, and 1/2 is what percent? 15%. So there is your circle/pie graphs